Welcome to Engineering Insight Academy, your own YouTube channel. So today I want to talk about calculus 1. I want to talk on the first topic, the limit and continuity. So I want to talk on limit and continuity. So I want to talk about limits and continuity. So first we want to see that what is a limit first. So what is a limit? So we want to know what is a limit. So what is a limit? A limit is a value which a function approaches from both or either side, which means a value that a function approaches either from the negative or from the positive, but it won't reach at that point. That's a definition of a limit. So at first we want to look at a graph of y is equals to x squared. This graph of y is equals to x squared. We both know this graph. It is like this. This is a graph of y is equals to x squared. This is the y-axis. This is the x-axis. So let's take, for example, here we have got 2. So we need to approach these two either from the negative side or from the positive side. So we know that a limit at point 2 is equals to what? Is equals to 4. Because if we put these two in this function, we'll get what? We'll get 4. But Jesus, we want the values that are behind these two. So we want numbers like 1.99. We want numbers like 1.98. The numbers like that. So if you see that if we put 1.9999 squared here, we won't get to 2, but we will find the values that are near 2. So these values are the what? Are the limits. But we know that our limit is 4, but we want the values that are behind what? Behind 2. So there is a general notation of a limit. A general notation of a limit. So there is a general notation of a limit. Let's say, for example, we are given a limit as x approaches a of f of x is equals to L. So this is a general notation of a what? Of a limit. So this is a general notation of what? Of a limit. For example, given a limit something like a limit as x approaches 2 of x squared. The first stage to deal with when dealing with limits something such like this, you have to do the substitution method. The substitution method first. You have to do the substitution method. If the substitution method didn't work, then I will teach you later how to deal with such function that won't obey the substitution method. So here we have to put these 2 into this x squared. So we'll get 2 squared and we'll get 4. So the limit of x, or the limit of a function of x squared as x approaches 2 is equals to what? Is equals to 4. So let's say, for example, b, we are given again limit as x approaches 3 of x cubed plus 2. Of x cubed plus 2. So we first try the substitution method. Then we have limit as x approaches 3 of x cubed plus what? Plus 2. Then we have to substitute this 3 here. And 3 cubed plus 2. And we will get 3 cubed is equals to 27 plus 2. And if you say 27 plus 2, we'll get 29. So 29 is our limit L that we have talked about here. So we know that L is our what? Is our limit. Then we want to move to such limit. Let's say in the exam, you are given a limit like x limit as x approaches 0 of sine x over x. This is A. Then B, you are given limit as x approaches 0 of cos x over x. Something like this. Then the first stage that you have to do is to differentiate. So you have to differentiate using a rule of L'Hopital. So you have to use L'Hopital's rule. So L'Hopital's rule goes like limit as x approaches a of f of x over g of x. If you tested your a, then it is undefined. Then you have to differentiate the numerator and differentiate the denominator. So it goes like limit as x approaches a of, if you differentiate f of x, you get f prime of x over g prime of x. Then we have to substitute our a. Then we have f prime of a over g prime of a. So this will be our limit L. So let's work the questions that I have put on top. A, we have got limit of x approaches 0 of sine x over x. So it goes like limit as x approaches 0. Then you have to differentiate this sine x and you get cos x. If you differentiate x, you get 1. Then we will left with limit as x approaches 0 of cos of x. Then we have to substitute this 0 on x and you get cos of 0. Cos of 0, which gives us 1. So 1 is our limit. So a limit of the function sine x over x as x approaches 0 is equals to 1. Then B, we have limit as x approaches 0 of cos of x over x. So we are using L'Hopital's rule. We will say limit as x approaches 0. If we differentiate this cos, we will get negative sine of x over 1. Then if we differentiate this x, we will get this one. If we differentiate cos, we will get negative sine. So we will rewrite negative limit as x approaches 0 of sine x over 1. If we substitute here, we will get negative sine of 0. Negative sine of 0 is equals to 0. So the limit as a function of cos x over x approaches 0 is equals to 0. So we want to move to indefinite limits. The indefinite limits. The indefinite limits, these are limits that when you substitute, you get something like 0 over 0. You get infinity over infinity. You get infinity over 1. You get something like e to the infinity. etc. There are not such answers. So let's take, for example, a limit as x approaches infinity of 3x squared plus 1 over x squared plus x, something like this. We want to deal with this limit. So if we substitute this infinity, we will get 3 infinity squared plus 1 over infinity squared plus infinity. So definitely we'll get something over infinity, which is undefined. It won't exist. So we have to make this limit exist. So how do we make it exist? We use another technique. We check at the denominator. If we check at the denominator, our variable with the highest power is x squared. So you have to divide each and every term of the function with x squared. So we will say limit as x approaches infinity of 3x squared over x squared, which is this one, plus 1 over x squared over x squared over x squared plus x squared plus x over x squared, something like this. So we have to cancel here and here. You have to cancel here and here. Then limit as x approaches infinity. Then you're left with 3 plus 1 over x squared over 1 plus here 1. Here we're left with 1x only. So 1 over x. If we substitute on x, we know that 1 over infinity, it tends to 0. So if we substitute here, we'll get something like 3 plus 1 over infinity all squared over 1 plus 1 over x, infinity. So these 1 over infinity and 1 over infinity squared, they converge to 0. So this one tends to 0, this one tends to 0. So we'll be having 3 over 1, so our answer is 3, which is the limit L. Let's say, for example, we are given something like, here at B, we are given limit as x approaches infinity of, let's say, for example, we have got 1 over x. We have got 1 over x. Then we know that as x approaches infinity, we mean that x is getting bigger and bigger until it tends to 0. So 1 over x as x approaches infinity is equals to 0. This is defined. So let's say, for example, we are given another question. Limit as x approaches infinity of, let's say, x plus 2 over x over x, let's say x cubed over x cubed plus 3x cubed, something like this. Plus, not x cubed. Let's put x squared here. So I told you you have to divide each and every term with the highest variable, with the variable with the highest power. So we say limit as x approaches infinity of x cubed over x cubed plus 2 over x cubed over x cubed over x cubed plus 3x squared over x cubed. So this one and this one cancel, this one and this one cancel. Then we have to say this one and this one. We are left with 3 over x here. Then we go like limit as x approaches infinity of 1 plus 2 over x cubed over 1 plus 3 over x. So if you don't want to substitute here, you just write when x approaches infinity, 2 over x cubed and 3 over x tends to be 0. So if this one tends to be 0 and this one tends to be 0, then limit as x approaches infinity of 1 over 1. So our answer is equals to 1. So this is our answer, right? So we want to move to the trig limits. So we want to talk about the trig limits. So let's say we are given limit as x. So we want to talk about the trig limits. So let's say we are given limits as x approaches 0, let's say of sine x over tan of x, something like this. If we put sine of x and over tan of x, the first step is to do the substitution method first. If we substitute sine of 0 and tan of 0, we'll get 0 over 0, which is undefined. So we have to make this whole function defined. How do we make this function defined? We have to use the trig. We know that tan of x is identical to sine of x over cos of x. So limit as x approaches 0 of sine of x over tan of x is equals to limit as x approaches 0 of sine of x divided by tan. We have said that is sine of x over cos of x. Then limit as x approaches 0 of sine of x. We know that if we multiply, we put a reciprocal of sine x over cos x, which is cos of x over sine of x. Then if we cancel here and here, we will be left with limit as x approaches 0 of cos of x. If we substitute here, substitution now works. This is defined. If we say cos of 0, we'll get 1. So 1 is our limit L that we were looking for. Then again, you can use small angles. Small angles from your A level. We know that sine of x is approximately to x when x is small. When x is small, sine x is approximately to what? To x. And cos of x is approximately to 1 minus x squared over 2. And we know that tan of x is approximately to what? To x. So let's see the example that we're looking at. Limit as x approaches 0 of sine of x over tan of x is equals to, we talked about the small angle. So you can write limit as x approaches 0. You know that the small angle of sine of x is equals to x. The small angle of tan x is equals to x. Then we will have limit as x approaches 0. This one and this one gives us 1. So limit of a number is equals to that number. So the answer is 1. So you can use this one. So even if we go back to limit as x approaches 0 of sine x over x, we can use the small angles here. We can say limit as x approaches 0 of the small angle of this sine x is x over x. X over x. If this cancel, we get 1. So we have limit as x approaches 0 of 1. So a limit of a number is that number. So the answer is 1. So we now want to look at rules of limits, or what we call the theorems of limits. So the theorem of limits, the first one that we have is limit as x approaches a of f of x is equals to f of a if this is defined. So we can write this limit as x approaches a. Then b, the second theorem goes like limit as x approaches a of f of x plus g of x. So it's plus or minus, right? is the same as limit as x approaches a of f of x plus limit as x approaches a of g of x. Something like this. Then we have the C1, the limit as x approaches a of f of x over g of x, which is the same as limit as x approaches a of f of x over limit as x approaches a of g of x, which finally gives us f of a over g of a. So this is our answer for this question. So we want to move to the next question. So the next question that we want to look about, want to look at the next question. Let me check the question first. I want to check the question. I want to check the question for you. Sorry. So let's say, for example, we are given limit as x approaches infinity of 2x to the 4 plus our x over x cubed minus 1, something like this. We have said that you can check the variable with the highest power. So the variable with the highest power is x cubed here. So it goes like limit as x approaches infinity of 2x to the 4 plus x over x cubed minus 1 is equals to limit as x approaches infinity. So we said that you have to divide everything using the highest power on the denominator, the highest variable, the variable with the highest power on the denominator. So it goes like 2x to the 4 over x cubed plus x over x cubed over x cubed over x cubed minus 1 over x cubed. Something like this. This nullifies to 1, and this one cancels this, and we are left with 2x on top. So we now have limit as x approaches infinity of 2x. Here we have x squared plus 1 over x squared over, here we have 1 minus 1 over x cubed. Then we have to write this statement when x approaches 0. 1 over x squared, comma, 2x, comma, negative 1 over x cubed nullifies to 0. So this one nullified to 0, this one nullified to 0, this one nullified to 0. So we are left with the limit as x approaches infinity of 0 over 1. So 0 over 1 exists, we will have a 0. So 0 is our limit L. Then now we want to move to the continuity.